Okay, so hi everyone. I'm Tiberius Axinte from Bitdefender, and today I'm going to talk about APT28 on Mac. APT28 is a known threat in the industry, but it's relatively new for the Mac ecosystem. And we will focus this presentation on the backdoor component of APT28 on Mac, which is XAgent. As an agenda for the presentation, first we will take a look at the APT28 on all platforms, and then we will try to follow the APT28 attack flow on macOS. And after that, we will dissect and analyze the XAgent component of this attack, starting with the communication between the agent and the CNC servers. Then we will see the list of commands that the malware can execute on the infected machine. And the most important part, we will analyze every spying module that this backdoor has. And in the end, we will conclude with a comparison between the Mac version of XAgent and XAgent from all the other operating systems. So APT28 was studied by many vendors from the industry, and generally speaking, most of them seem to agree that behind those attacks, there's a Russian-based threat actor responsible for multiple campaigns against a vast number of countries and organizations, countries from all around the globe, covering most of the continents like North and South America, Africa, Europe, and Asia, targeting institutions and organizations from the Eurospace, government, energy, defense, and even media sectors. So according to some early publications about APT28, it seems like it has been operating since as early as 2004. The 2014 is the year that the first Linux sample was discovered, followed up by the iOS sample in 2015. 2016 was the year that the first Android and the first Mac component of APT28 was discovered. The Mac component actually is the downloader for the XAgent component that we've discovered last year. So the APT28 attack flow on Mac has three stages. First, it starts with PDF, with an email attachment, which is a PDF document that when opened by the victim, it will be displayed on the screen with the title Russian Federal Space Programs Projects. And here are a few pages from that document that includes aerospace research information, satellite placement, and so on. But actually the execution will continue in the background with the second stage of the attack, which is the downloader. This sample has download, execute, and ensure persistence on the system for the third and the final stage of the attack, which is XAgent. And all these three stages sums up as a spear phishing attack. Okay, so XAgent is the final payload of a successful APT28 attack on Mac, and it is used for data exfiltration. So we will separate our analysis in three major parts. First, we will analyze the communication between the malware and the CNC servers. Second, we will see the command list that the malware can receive from the server. And third, and most important, the spying modules that the attacker will have after a successful attack with APT28 on a Mac machine. So first, let's take a quick look at the communication between the agent and the CNC servers. The CNC server list was hard-coded in the sample, and it consists of 4 domain names that try to impersonate Apple domain names and one IP address. When we analyzed the sample, the domain names were not registered and were used only as a backup, but the IP address was up and running from a host from the United States, and actually another IP address from the same network was used by the APT28 group for external payload for an attack against the Democratic National Committee. The communication process between XAgent and the CNC server consists of three main threads. A get thread used to to get commands from the server and insert them in the command queue. A second and a post thread used to get data from the data exfiltration queue and send it to the CNC server. And a third and a main thread that will execute those commands and then insert the results in the data exfiltration queue. So in order to communicate with the CNC server, XAgent uses a protocol based on HTTP post and get messages. The URL is generated for every message and includes an identifier for the victim. The body of the HTTP message is used to send and receive data from the server, and this data is encrypted with RC4 and on top of that encoded with base64. So let's take a look at how data is received, is sent to the server, is exfiltrated. Here is a post request message, which actually is the hello message that the malware sends to the server just after it was executed. So if we take a quick look on how the URL is generated, first a domain name and a var are chosen from two hard-coded lists, and then a marker and a token are appended to this URL for victim identification. And in the end, a random number of parameters with random generated base64 values are appended to the URL. The marker and the data token are base64 strings. And if we decode those strings, we obtain 15 bytes, which start with 4 bytes used to encrypt the next 11 bytes. And if we decrypt those, we obtain a data token used for message integrity and the first 4 bytes from the unique machine identifier from a Mac machine. Okay, so now we've seen how the URL is generated. Let's take a quick look at the data. It's also a base64 string, and if we decode that string, we obtain a buffer that starts with a 4-byte key used to encrypt a data token and an agent ID also for message integrity and victim identification. And then we have an RC4 encrypted buffer prepended by a checksum for that buffer. So if we take a look at data buffer, the data buffer is encrypted with an RC4 algorithm with a 54-byte length key, where the first 50 bytes of the key are hard-coded in a sample, and the last 4 bytes are generated every time a new message is sent to the server. So if we decrypt that message packet, we obtain a module ID, which is a 2-sequence number. The first byte represents an identifier for XAgent, and the second byte is the XAgent's version, which in our case on Mac is version number 3. A command ID, which is 2 for the hello message, and then a sequence of bytes that represent every spying module that XAgent have registered on the infected machine. Also a data size and a priority for that message. Okay, so this is how data is sent to the server. Let's see how it can request commands from the CNC server. So here is a get message that the malware does in order to receive a command from the CNC server. And it will also receive a command packet with which structure is formed by a command, a parameter, and the size for that parameter. This data is also encrypted with RC4 and then on top of that encoded with base64. So this is how XAgent communicates with the CNC server. Now let's take a look at the commands that it can receive from the server. So here is a table with all the possible commands that the malware can receive for the CNC server. Each command is a 1-byte size command, and for every command that it receives, XAgent will call a function from a spying module, and these commands are also complement each other. Like for example, the CNC server can send a command to XAgent to take screenshots on that infected machine, and then can send another command to upload those screenshots to a FTP server. So now that we've seen how XAgent communicates, how it exfiltrates data, how it can receive commands from the server, now let's take a look at the spying module that it has and their capabilities. So bootx loader is the main module of the XAgent, which is the entry point. First, it will check if a debugger is present, and if so, it will break the execution. Then it will check for internet connectivity against Google DNS. And after that, it will start those two main threads that we've talked about. And a main thread used for the logic of the backdoor, and also that will load all the other spying modules. Using the launcher module, the malware can relaunch itself. First, it will move the sample to a different location on the disk, which is generated in the current user directory, and it will choose a random directory name from a list that also impersonate Apple directory names, and it will start with a dot, so it will be hidden from Finder, so File Explorer on Mac. And then it will choose a new file name, and in the end, it will start a new process from the newly created path on the disk. Using the info OS module, XAgent will gather information about the infected machine, such as operating system version, the unique machine identifier, the current username, and also the current process list. And all this information is HTML formatted before it's sent to the server. So the attacker must have an HTML-based interface where he can see all the infected machines. Using the HTTP channel module, XAgent communicates with the CNC server, those two get and post threads, and a class called HTTP channel that stores some fields like this is the active channel for communication, arrays for commands, and arrays for data to be exfiltrated. This channel also, before sending in any message, it will encrypt and encode using the encoder and encryptor modules. The encoding is done using a base64 URL friendly, where minus is replaced with plus, and underscore is replaced with slash. And the encryption module uses an RC4 algorithm with a 54-byte length key, where the first 50 bytes are hard-coded in the sample, and the last 4 bytes are generated every time a new message is sent to the server. Also using the file system module, XAgent can list, create, delete files and directories on the disk, but it can also execute the newly downloaded files from the CNC server. Also using the FTP manager module, XAgent can connect to a FTP server using credentials received from the CNC server, and with this module it can exfiltrate data, but it can also update the already registered spying modules on the infected machine. XAgent also can record all your keystrokes using the core graph event tab create, and then it will also format as HTML this log file, and then it will send it to the CNC server. Using the password module, XAgent can read all your Firefox passwords from the logins.json file, and by using the network security service libraries, can decrypt those passwords, and then it will also send them to the CNC server. It can also take screenshots using core graphics APIs. It will collect those screenshots at every 10-second interval. Then it will resize them to an 800 by 500 resolution. And then by using the FTP module, it will upload them to the CNC server. The 10-second interval can be modified as requested by the server. XAgent can also inject code into the running applications. First, it will list the application names, and if one application matches with any applications from a hard-coded list, then it will force AppleScript to load in that application, and by using AppleScript events, it will inject code in the bundle applications. As a side note, in 2015, As part of a massive hacking team, a private intelligence contractor who develops and sells hacking tools to government around the world was hacked, and then their remote code system, including the Mac implant source code, was leaked on GitHub. And one interesting features in the leaked code was application injection using APT events. And if we compare their code with the one from the XAgent component that we found, we can see that it's basically identical. Even the class names and the method names are the same. So this can be another example of malware writers reusing the hacking team's leaked code from the GitHub. Another module called remote shell can be used by the attacker to remotely execute shell commands on the affected machine. But this module has an interesting function called check backup iOS device folder. And by using this, the XAgent will list all your iOS backup folders that you have on your Mac. It will send that list to the CNC server. Then the server will choose iOS backup and request the XAgent to upload it to an FTP server. So in an iOS backup, there's a lot of sensitive information like all your messages, all your contacts, all your calendar events, Safari data and browsing history, and also call history. So as we know, APT28 attacks targets high-profile individuals, and if such an attack succeeds, it can see where a person is from the calendar events, who is he talking to from call history, or what business it conducts from the messages, and all this information from an iOS backup is very, very sensitive. There was another module called Camera Shot, but it wasn't implemented in this version, maybe in the future ones. So that were the spying modules that XAgent has. Now, to finish with a comparison between the Mac version and the Linux and iOS versions of XAgent, communication-wise, they are basically identical. URL generation and tokens used to identify the victim are basically the same. And if we even compare the code between iOS and XAgent, there are the same class names and method names. But if we compare the spying modules between Mac and Linux, we can see that there are a few that are common, like the HTTP channel, the encryption module, the encoding module, but the Mac version has way more spying modules than all the other platforms. So as a summary for the presentations, we've discovered the sample last year in 2017. XAgent completes the APT28 attack puzzle that was missing, or piece was missing. We only have the dropper and the downloader from the 2016. And as we've seen, the Mac version has the most spying capabilities, so we cannot say anymore that Macs can get malware, right? Thank you.
Thank you so much for your talk in the name of Adobe and BSide, and let me give you this gift from us.
Thank you. Thank you for having me. Have a nice day.